Okay, so we're just going to up things a little bit. And the 2 times 2, well, what if we did 2 times 3, which is a binomial times a trinomial, or how about a trinomial times a trinomial? Okay, so we want to use what we just learned to be able to apply that and to take it up just another notch. Now, let's just kind of review, though. What are like terms? Nazi? What would you say? The same variables. So basically, it's like terms are like the same words. So if you had 3x squared y plus 2x squared y, this would equal 5x squared y. So you notice how the x squared y doesn't change, but the number of them does. And that number's in the front. Okay? So when you have 2 cats and 3 cats, you don't have 5 cats squared, right? So when you're adding and subtracting, just do like you always did, and you'll be fine. Do not change the cats. Don't change the word. It's the number of words that will change, if it's the same word as another one. Okay? So examples of like terms, these are all the same, right? See how they're all xy squared, xy squared? Now, let's get right down to simplifying this one right here. Now, the way this one works is the 5x. The 5x will multiply to this one, and this one. Then you'll take the 2, and you'll multiply it to this one, and this one. And then after you've done all that multiplication, you do what? Combine like terms. And then you're done. So lots of stuff going on. And this is taking you to a whole other level than grade 9. Great. And grade 11 is a huge jump from grade 10. It's not such a bad jump from grade 9 to grade 10. It used to be huge, right? And then they made the 10C. But this unit is the most important out of all of them, because you have to be able to know how to do this stuff just automatically in grade 11. And it's kind of like grade 10 you learn the alphabet, and then in grade 11 and grade 12 you really start to do writing and things like that. And if students still don't know the alphabet, they really struggle, as you can imagine. Okay? It's pretty hard to write an essay if you don't know your alphabet. It's pretty hard to write a sentence. It's pretty hard to even write a word. And that's what we find in grade 11 and grade 12. People don't know this unit well. So let's just kind of do it together. So I'm doing with the red, the 5x now. So I will do it in red down here. What's 5x times x squared? 5x cubed. Remember, there's a 1 there. We multiply the numbers, add the exponents. Plus 5x times 2x, 10x squared. And you can see that one little mistake in here, you will get the wrong answer. Okay? There is many places to make a mistake. 6 multiplications to make a mistake, and then combining like terms. So it really ups your game a lot. Okay? 10x squared, and then 5x times 1, 5x. Question? You multiply powers, therefore you add the exponents, right? X squared times x to the 3 equals x to the 5. Okay, now let's do the blue, the bottom. 2 times x squared. 2x squared. 2 times 2x. Just 4x, right? forgot my squared on the last one. And then 2 times 2 is 2. Okay? So that was all the red multiplied together, then all the blue multiplied together. Now we've got to find any like terms. How about 5x cubed? Does it have anybody to play with? Okay, so that one just goes 5x cubed and cross it out. How about, is there any other x squareds? Okay, so we can go like this and like this. Taking what's up? Five times 2 is 10. That's this one here. And then 5 times the 2 is 10, right? Like this 2 right here? This 2. No. The 5x gets multiplied to everybody first. That's all the red. See the red lines? And then 2 gets multiplied to all of them. Those are all the blues. Okay? So we got 10x squared and 2x squared is? So that's plus 12x squared. And again, cross them out so you know you got them. 5x and 4x is 9x. And then 2 has no one to play with, so you just put that down. So there's actually nothing new here, just a lot more of it. Okay, so we don't have to do A or B. Let's go to C. Okay, now C is not 2x cubed minus y cubed. Okay, if life was only that easy. When you have a binomial, you have to turn it into 2x minus y times 2x minus y times 2x minus y. So you can only do 2 at a time when it's binomial times a binomial times a binomial. So I pick the last 2 and I do them. So I'm going to do that. So I've got 2x minus y over here in the front. Now in the red, I will, how do I find the answer to that? What 4-letter word will I use? Be careful. Foil, yes. Okay, so 2x times 2x, 4x squared, 2x times y, negative y. Then, now we're going to do the insides. 2xy and negative y is plus y squared. So now we have 2x minus y times 4x squared times 4x squared plus or minus. What's next? 4xy plus y squared. Now guess what we do? So this would be the same thing as 2x getting multiplied to these. So let's try that out. What's 2x times 4x squared? 2x times negative 4xy. Negative 8x squared y. Okay, and then 2x times y squared. 2x y squared. Okay, now we're going to take, what are we going to take and multiply to all of these? What is that thing? A negative y, isn't it? So be very careful. So what is, now we're just doing the negative y. We just finished doing the 2x. So negative y times 4x squared. Negative 4x squared y. Negative y times negative 4xy. Positive 4xy squared. And negative y times y squared is negative y cubed. Now, you could have put a negative 1 here, and maybe that would have made it easier if you put negative 1 there. Now you can start to see the mess we're getting, and that's why organization is such a key thing here. Now, eight x cubed. Anyone to play with? No. So 8x cubed is all by himself. Okay, I got a negative 8x squared y. Is there another x squared y? So there's this one, and there's this one, and is there another one? No. So we would have negative 12x squared y. Cross them out. Okay. 2xy squared and 4xy squared. 6xy squared minus y cubed. Fun, hey? So fun. Okay, those aren't fun. What's wrong? Which one? Yeah, you know what I always do? I move it. I'm just, because I do this. This is how I do it. And then I do, because it's so much easier. It's actually less work. Okay, that's a good question. Okay, yeah. You thought those were fun. A trinomial times a trinomial. This is why you get up in the morning every day. For this kind of question right here. Now, so this one, we are going to take 3x squared, and we are going to multiply it to that one, to that one, and to that one. Okay? So, this is like doing 9 questions at one time, because you have to do 9 multiplications to get this long thing that then you will add like terms. So it's like the entire last unit, right? Except for the radicals times 9. So let's do this one. What's 3x squared times x squared? 3x to the 4. We multiply the numbers, and then we... Okay. Now, 3x squared times negative 7x. Negative 21x cubed. 3x squared times 2. 6x squared. Can you just imagine the things that are going on in the brain right now? It's going, holy crap, okay, hold on, easy, whoa. So we multiply this, then we add this, then we got to take this over there, and then we got to do 9 of these. You won't be the same after today. Now, the 2x. So organization is key here, obviously. So this is the strategy I use. I will circle it, and I will draw the 3 arrows, or maybe I will draw the arrow, do the question. Draw the arrow, or sorry, do the answer. Draw the arrow, multiply them, put the answer. Okay? So, this is how I would do it. I would go like this. Okay, 2x times x squared would be 2x cubed. Then I go and I will do the next one. 2x times negative 7x is negative 14x squared. Then I will take the 2x and multiply it by 2, which is 4x. Okay? Now I will circle the 1. And then I will do 1 times 1x is 1x squared. Sorry. And then 1 times negative 7x will be negative 7x. And then 1 times 2 is 2. Okay, so there's the blue, the red, and then the black. Now, let's look at 3x to the 4. Anybody to play with? Okay, so make sure you cross it out and write 3x to the 4. Remember I was telling you, you're going to have these long ones, and you're going to want to make sure you keep track of everybody. This is the one I had in mind. Okay, now I got 21x cubed. Do I have another x cubed? Okay, so I got a 2x cubed. I'll keep looking. Is there any more? No, so that would give me negative 19x cubed. And I will cross them out. In case I come across another x cubed later, then I know, oh, I missed them. Okay? As opposed to, I'm pretty sure I got them. You know, I'm pretty sure I got them. I cross them out. Now, 6x squared. Anybody play with? Negative 14x squared and 1x squared. So that is negative 7x squared. Okay? Now, 4x and negative 7x is negative 3x and plus 2. Now, if this was a unit exam, and you got that question, you did the question, you're done. You've gone through the test, you're done. How do you know if you got D right? I actually gave a test like that one time, where the answers were on the back. Well, so someone came up like halfway through, like, Mr. Jeff, all the answers are on the back. It was my replacement exams at the end of the year.
You just put the answers on the back and other answers.
So, well, I don't know if that would be nice. Yeah, somehow I had my answer sheet and it got in there when it went to photocopying. It's like, don't leave without me. And it hung on and made it. So, anyway, I'm going to try my best not to leave answers on the back of your exams. So, what would be your other way of doing this? And I can guarantee the diploma will not have the answers in the back, unfortunately. But you wouldn't believe how many questions in the diploma. Because, you know what, and this is the absolute truth, every one of you will go into the diploma knowing what you're doing. But you won't, you can never get anybody, because I wish I had the secret formula, because I tried it myself, you can never get rid of stupid mistakes. Like 1 plus 1 equals 3 some days, right? Or you forget the 2 when you multiply x times x, right? How do you catch that stuff? Yeah, this one doing it again, like what I would like to do for myself is like I'm done the test, I just want to see if it's right. Okay? So here's a way that you can do it. Okay? This is a way that you can show on your calculator. Now, you could put a number in for x, first of all, couldn't you? Put it into the question, put it into the answer. But here is another way of doing it. So I want everyone to get out their calculator. And I want you to hit y equals on your calculator. You look where my arrow is. I have an arrow up there so you can see it. Now, I want everybody to put in the question. Now, you want to put it just like it looks. So you're going to put a bracket, and then it's 3. X is this button here. Everyone remembers that, right? 3x, and the squared button is right there, plus 2x plus 1. Shut that bracket. Open another bracket. You can put 1 x squared minus 7x plus 2. Now you can use the exponent button over the division sign, or you can use just the squared button. They both mean the same thing. Double check, 3x squared plus 2x, 1. And then hit zoom. Zoom is right here. See where the arrow is. And then hit 6, which is standard. So we're all in the same graph. Okay. Now that's just part of it, but it's enough to be able to show you what I'm talking about. Okay, let's just get through this. So now, how do I know if my answer is correct? The equation is the words. This, what you're looking at, is the picture of that words, or of those words. They are the same thing, okay? If I want to go to y2, so I'm going to go down to y2, and I want you to go all the way left till you're blinking on that line. And then hit the enter button, and it should turn it to a thick line. Okay, now come over here. Now I want you to put your answer in. 3x. Now in this case, you're going to have to use the exponent button to the 4 minus 19x cubed minus 7x. And you could either go to the exponent 2 or just squared. Minus 3x plus 2. Okay? Now what do you know about y1 and y2? They're the same. I mean, if they weren't the same, that's how you know you made a mistake. How do you know you made a mistake? You hit graph. First one is there. Here comes the other one. It'll go right on top of it. That is your confirmation that you got the right answer. And it makes sense. If they're the same descriptions, they should give the same pictures. It's just y1 question, y2 answer, zoom 6. Oh, and make sure for the answer, you do the line thicker, or else you won't even know if it's falling on top of the other one. And I know what you're saying. You're like, oh, but I would know because it's not making a graph any other place. But it could be making a graph way, way, way in left field, and you're thinking, oh yeah, I probably got it right. Right? So if you make one, the thicker one, you can see it go right on top of the other one. So it's a really good way of checking. And you know, when students come up to me during a test, and they say to me, I know I got this one wrong, I checked it, I can't see where. I'm willing to help them. Because they've done the step, they know what they're doing. Knowing how to check your answers is a whole other step that really is great for getting you ready for the diploma. Yes?
When you press Y equals 33 in the question, do you have to hit zoom 6 or can you take that?
No, you want to hit zoom 6 because if you don't hit zoom 6, here's the window settings for zoom 6. It brings it back. If you're if your window settings are all messed up from some other question you've done a long time ago, it'll mess you up. And I get us all to hit zoom 6, or else we'd all be looking at different pictures right now. Cheeky. Well, the keystrokes are your numbers, your variable, which is here. Do you see that? That's your x. And squared is here, or the exponent button is here. That's all the keys you need to know. And then after you're done graphing y1, y2, it is zoom 6. Yep.
So you can hit zoom 6 after you've done everything.
Yep. Yep. You can do it before or after. Now, I put an extra thing in, an extra x in mine, so it's messing. Because you've made an error putting it into your calculator.
But like, what's syntax mean?
Usually a coding error. Yep, question?
Can you assign x a value and one equals
Yeah, you can do that. But it is actually longer. And students make more mistakes doing substitution. That's a whole nother arena. Whereas I can look at this and look at my question. Okay, they are the same.
yeah, but you can assign
Yes. Yeah, you can do that. Yeah. The only thing is you will get coincidences sometime, unfortunately. Whereas this is not a coincidence. This is testing 8 billion points. You're just testing one. So I can test 8 billion points in less time than you can test one. So that's why I do this. It's actually 8 trillion gazillion. I just thought of 8 billion, so you guys wouldn't get overwhelmed. Yep.
Wait, so for like if you're doing if you're trying to answer another question, do you have to erase like what you put on the graph? How do you erase it?
You gotta go to Y and clear.
So all you have to do is go to Y, and you can go, actually, if you go to the very, very right and hit clear, or no, just hit clear here, sorry, when you're on the equal sign, and then if you push right, it's not doing it, I guess you got to be right there. So you just have to be right after the equal sign and then hit clear. Yeah. Okay, next, E. Now this one here, does anybody know how to tackle this one? Yeah.
Okay, then you do 2x, like you do the 2x minus w, then do it again, then put like bigger brackets around, like first you would do,
This isn't a square, remember, this is 2 times. So the only thing you have to do is you can take the 2 in right there. Don't take it into the other one, just the one that's right beside. So that is 2x or 4x minus 2w, and that will be times the 4x plus 7w that was already there. Okay? Now, students know that 2 times 4 times 8 is what? What's 2 times 4 times 8? 64. Because this is the same thing as 8 times 8, which is 64. Do not do this. It is not the same thing as 8 times 16. So you don't multiply to everybody because it's a multiplication. You only multiply to the first one. Don't get that mixed up with when you had 2 times x plus 3, that you do distribute. Okay? Like if you have 2 times a plus b, or sorry, a, b, c, what's the answer to that? No. 2a, b, c. 2a plus b plus c would equal 2a plus 2b plus 2c. Okay? Mathematics is so similar, that's why it gets confusing. Okay? Now, this one here, because I don't want to go through these over and over, I want you to be practicing today. How would you go after this to do E? What would you do next? FOIL, yes. Okay, now F. F, remember, is the same thing as negative 3 times x minus 1 times x minus 1 times plus x minus 1 times 4x plus 5. What would you do next? I heard it. Multiplication. Be specific with me. What am I multiplying? Okay, so you just want to bring the negative 3 into here, which would be negative 3x plus 3 times x minus 1 plus x minus 1 times 4x plus 5. Just like I only bring it into, if it's a times b times c all times 3, do I just bring it into the first one? Yep. 3a, b, c. See, I just brought it into this one. So if you're doing this, it's 3a, b, c. Not 3a, 3b, 3c. That's why I did this example here. Okay, make sure you know the difference between these two. Good to have on a study sheet. And if you're not differentiating, that's probably because you've never had the two things beside each other to start making similarity and difference statements in your head to be able to write down on a piece of paper. Now, do you see up here, I did not take the 2 and multiply everything, just the first term, or the first, binomial. Now, how would we solve this? Yep. Foil that. This you would also, then you have to add like terms. Okay? Yep. When? You have to be specific. Like here, why do I add? Because this is this binomial multiplied by this binomial. Okay. Applying. I need to get going on this stuff. Now, here we have a picture surrounded by a frame. And I want you to change this to meters, all of these measurements, okay? Because the centimeters is confusing to students when we're dealing with a picture. A 3 centimeter by 2 centimeter picture is not really realistic. Now we have this picture that's 2 meters by 3 meters. That's the outside dimensions. Okay? So this is like the length. And this is the width. So we got 3 meters by 2 meters, right? Now, how big is the picture? It says let x represent the thickness of the frame. So from here to here, this is our x. Okay, so if here's the picture, the picture doesn't show up very well, so I will draw you a nicer one. Ready? It's not done yet. Oh yeah. No, it's time for a striped worm, I think. I know. There isn't a day goes by that I don't say that to myself. Now, I want just the dimensions of the picture. What are the dimensions of the picture? The star stripey thing. I need just the dimensions of that. That white part is the frame. Okay? This is the frame.
Well, you'd have to figure out the freaking picture.
No, if it's, I just want you to look, you guys. From here to here, this corner to this corner, how long is it? 3 meters. Okay? Now, if this is x from here to here, and this is x, what is this?
I thought it was 3 meters from
Yeah, it's a picture.
It would, okay, guys, what is it? 3 minus x minus x. So it's 3 minus 2x, right? If this is x and this is x, right? Then this part here must be 3 minus x minus x, right? Which is 3 minus 2x. That's the length. The width would be 2 minus 2x. So you say, well, what would the expression be for area? Well, it's length times width, right? Which is 3 minus 2x times 2 minus 2x. It is. Yep. Okay. Now, what is the, oops, this should be actually up here. Oh no, I'm right. I'm looking for, yeah, there it is, good. Okay, so, how would I do this? FOIL it. So, what's 3 times 2? 6. 3 times negative 2x. Okay, and then negative 2x times 2. Negative 4x. And then negative 2x times negative 2x. Okay. So, in order of degree would be negative 4x squared. Positive 4x squared, yep. Minus 10x plus 6. That's the area of the picture. Now, what's the area of everything? Like if it was sitting on your wall, how do you find the area of that entire thing? It's just 3 times 2, right? Area equals length times width, which is 3 times 2. Area equals 6 meters squared, right? So it says, how do you find the area of just the frame? Yep. So we want, so area frame equals the entire area of the entire minus the area of just the picture. If you need a reminder of what the picture looked like, it's right there. Because they're so transparent. I can tell that's what you wanted so bad. Now, area of the entire picture was 6 minus, and make sure you put this in brackets or you will get it wrong. Okay? So what is the area of the picture? 4x squared minus 10x plus 6. Now, why can't I just do this? I don't have to be so picky in math all the time. Why can't we just do that? Because I need to minus all of that. And if I just take the brackets out, it'll only actually be minusing the 4x. If you do this, the negative will go into, and it will make everything. So this will be 6 minus 4x squared plus 10x minus 6. So, What happens to the 6's? They're gone. So your answer is negative 4x squared plus 10x. Now, does this make sense? If x was 1, it would make sense, right? Because 1 squared times negative 4 is negative 4 plus 10, it's 6. But if x starts to get 3, 4, or 5, that means your frame's getting too big. Your frame's just overwhelm the picture. Do you see that? So there is a point where you can't have more frame than picture. Right? So you can't totally cancel your picture out, or else you haven't framed anything. You just have a big frame. I think that's called a piece of plywood, right? You could just tell somebody, put up a piece of plywood and go, no, it's a little molecule inside. Yeah. Yep. Okay. Okay. One more, and then. Now, we're not going to go through all of this, like, to get the final answer, but I just want to know how we would do it. It says, find the shaded area. Well, you guys have done these a lot, but not with expressions. Yes? Right, so if you take the entire area of all of it, and just subtract that little corner, now can you find the area of the corner? How would you do that? Multiply x plus 2 times 3x plus 1, right? That would get you that. The question would be, can you find the area of the large rectangle? What? What would be your dimensions? Okay, so this would be 7x plus 10. And this would be 3x squared plus 8x plus 4. Okay? So the last thing that I'm going to leave you with is what would be the equation? That's a nice multiple choice question. What would be the equation to find out the area of this? So area of this, we said should be area of this minus area of that, right? So, how do you find area of the large rectangle? What is the length?
Is 3x squared.
Okay, I always like to pick the longer as the length, but that's just me. Times 3x squared plus 8x plus 4. And then minus that little guy, x plus 2 times 3x plus 1. Okay, and this we've done already. This we've done already. And then you have to combine terms. Okay, so instead of using this time to keep on doing notes, I think you guys need to practice it, and the more practice you get done in class, the better. Okay, so there's your questions. Okay, and you guys have the same time the other class did, and about 10 people in the class got finished, and so I bet you the rest had just a couple left. So you want to get right at it, because if you waste a couple minutes, that's probably what you're going to be short by.